Cool. All right, so let me start now. Thank you for coming. So my name is John. I teach in the Interactive Multimedia Department at the College of New Jersey. And I teach classes like creative coding, digital fabrication, product design, data visualization, thesis. I've taught an Arduino class. I was just in the last session. That guy knew more than I did, which is pretty cool. Not sure if he's here. I learned a lot from his. So I've done a lot of stuff with Arduino. I'm teaching a little bit of like 110, which is like film and things like that. I'm getting more into that. But I also teach a class called Making Data Tangible at NYU. And they have this crazy program. Like NYU, it's the ITP program. It's kind of like Hogwarts for hackers. They have all this crazy technology. When you walk up the elevator, you don't walk up the elevator. I guess when you ride the elevator, and when you get to the fourth floor, when it opens up, the first thing that you see is this mirror that's made out of wood, and essentially you see your reflection, and there's like 800 servos that all change, like makes this really weird hissing noise. You see a reflection. Well, the entire place is like that. Like I went to grad school there, but I still teach there, and so when we do our Making Data Tangible course, it's a lot like what I'm about to show you today. So, give you a little bit of context where I am. I'm in Stockton, New Jersey, not in South Jersey, but more like it's closer to Central Jersey. So here's my shop. It's that little garage next to the van. That's where I'm sitting right now. And this is my shop when it's all cleaned up. And it's very rarely cleaned up because I'm always working on things. I teach in here now. I run a small company, which I'll talk about as well. We do a lot of digital fabrication work in here. And in fact, everything in the shop was paid for just using just freelance code. But actually what the shop looks like, this is actually me in real life. So it's a pretty small one-car garage, but it's got like a 3D printer there in the back. It's got a CNC machine with a bunch of crazy camera equipment on there. It's got a laser cutter. And I can't really turn the camera, so I can show you a little bit of this. It has some like basic woodworking tools. And so one of the things that I love to do is I love to mix creative coding, digital fabrication, and electronics. I like to mix all that stuff together. I was a web developer for 12 years, and cubicle life was not kind to me. Like I just didn't like sitting in a cube programming my guts out every day. Well, I loved it, and then one day I didn't. And then so that's when I bought all this woodworking equipment. I was doing a lot of freelance work, always doing a lot of freelance work. And so I bought all this stuff and to get away from the computer. But then something happened where all of a sudden the computers found their way back in. So that's my laser cutter. It's a Glowforge. That's a CNC machine. So it's like basically a router that's like on a robot basically arm. And then, of course, a 3D printer. So let me go back to here. Go back into Zoom. So now that we got everybody here, now I can officially start. Okay. So let me show you the project that I want to walk you through, because it's got a little bit of coding, actually a lot of coding, digital fabrication, electronics, and some drone shots, all kinds of stuff. So let me just show you what the project looks like. And you're like, what is that? So here it is. So that's it. And you're like, what is that? So that actually took like 4 months, and it's not even completely done. And I'll get to that. Like it's basically done. But it's getting close. So what that actually is, that shows how much solar radiation is over my garage at any given time. And it all started with a single line of code. And one of the things I wanted to do, I'm going to show you where I live, because I'm really interested in spaces. And like, when you get off like an airplane, which we probably haven't done in a while, but when you get off an airplane to a new place, and like when you walk outside, the sun feels different, right? Depending on where you are. So if you're in Florida or whether you're like in Seattle, like the sun just feels different. And so the way I wanted to sort of capture that. So I want to show you where I live, so you get some context of where some of this inspiration came from. I've got a video here. So this is taken from my drone. I got up 5:30 in the morning, which I always do. And so I live in a small town along the Delaware River on the New Jersey side. And it's got like this bridge that I go walk across every day. And it's a really quiet town. It's a really small town. There's a canal that you can walk along. And just so a lot of farms, like working farms and things like that. So we also have a garden. Like a lot of history. So it's like, this is basically how the town feels all the time. And so what I do is I've always wanted to take sunlight and like you capture it in a bottle for like when it's a really like cold day, and you can like unscrew the bottle and it all like leaks out and it's like summertime for a day, which I can't do, but instead I can visualize this. So let me show you what I found and how all of this started. So I'm gonna go to a web browser real quick. Actually, not real quick, for like a few minutes. I think you probably can see that. And so one night, I don't watch much TV because I don't like TV that much. But I saw this PySolar library, and essentially, when reading through it, it's got some stuff I still don't quite understand 100%. Even though I read like all the Wikipedia articles about it, I should know everything. And it had a little bit of code here, so I just like you guys, if you're just hacking, you just take that code, and I'll show you what I did. So I took that code, and it looks like, yep, we're importing a library into Python. Got something going on with a date, and you can pass it like a date and a location, which is pretty cool. And what that's going to do, if I run this in my terminal, clear, Python 3, PySolar test, and when you run that, it gives you a number. So I got the number 24, a decimal point, bunch of other numbers. So the first thing I did is like, what if I change one of these numbers? What if I change this one to be like, if I change this to be like 16 or something like that? What happens then? Well, I'll rerun my code. Now it's 59, right? But that was all I knew. Like, I didn't know anything other than like, oh my gosh, the number changes. And once I realized like that's how much solar radiation is at that exact location at that exact time, I wanted to see what that looked like. And they actually had like some visualizations already. Let's see if I can find them that looked like this. And I don't like visualizations that look like that. That doesn't like really tell me much of anything. I wanted to be able to hold it in my hand. And for me, like a lot of my projects are like that. So what I wound up doing is I decided to write some Python code that could just, with some for loops and things like that, get all of the numbers for every hour of the year, right? Every hour of the year, right? Just get all the numbers, and I'll show you what that code looks like. And it's actually cool to show you guys. Usually if I show people this kind of stuff, they don't really want to see the code because it's like, why would people want to see code? They don't understand it. So get radiation, and I know like there's cleaner ways to do it. This is throwaway code. You were never meant to see this. So this is my actual code, and I'll show you some stuff in a little bit. So basically, I know it's a cleaner way to do this. I know Brett already yelled at me for it, but basically this for loop just goes through every single day, gets all the data, does everything it needs, and it spits it back out. So so once I had all the data, then what I was able to do, you can go into, I created this thing in JavaScript that basically draws a shape based on that. So, and I'm doing it like, and I'll show you why it looks weird like this. I'm actually inserting things into databases, but this is the actual part of the code that matters. It creates like a big blob. So it starts like with a circle with 365 like nodes on it, and then it just basically pushes out each node from the center. That's this code right here, based on how much solar radiation there is. And then more bad code that I could have made cleaner. And then essentially it makes like a center hole for the dowel, which you'll see in a second. And then eventually it makes a zip, and you can download it. So to show you exactly what that did, so I took all that and I made a small little web app. So where do we want to check out? Anybody want to check out a cool place? I'll show you where I live right now, Stockton, New Jersey. That's where I live. And if I build this map, and it takes a little while because it's kind of doing a lot of math. And so 1 o'clock in the morning, there's still really no radiation, nothing noticeable. But once we hit 5 or 6 or 7, you're going to start to see a little bit. And so right now it's creating all of these SVGs. And we'll see it till the end. This looks way cooler when it's sped up, but it's all right. You'll see a clip like that later. But finally, everything's dark again. And after it's all done, I can download that zip. If I open up that zip, there's all these SVG files. So that's cool. Let me go back here. So any questions on that kind of stuff right now? So when I do this, I do a lot of visualizations like this, and every time I'll talk about a couple of the other ones. My coding's really messy. I just use what's quickest. Even for the web app, I use some PHP, and they're like, "Why don't you just use Flask and Python? Why would you make it complicated?" And it was just because I just didn't think of it. So I just use whatever code that I like. I use Python because that's just what I happen to be using in that day, and I'll use JavaScript for this because it's easier. So it's not meant to be clean because the final output is just like it's just a thing, right? It's not. No one's ever meant to see that code. But once I had the shapes, this is like the most exciting part. I was able to bring them to my laser cutters. Anybody use laser cutters here? Is that like a thing? Do you guys do that? You guys can talk. You don't have to, but I love laser cutters. Like I spend most of my day using laser cutters. Like to me, that's like the coolest technology in the world. So I took the shapes because you don't know really what it looks like until you put it all together. So let me show you what I did with the Glowforge. So it's like a little laser cutter. They're like $2,500. And I just load in all the shapes and just let it go. Yeah, they're just almost identical to the Cricut machines. They just, yeah, it's almost the same mechanic, just if this one happens to have like a laser beam that can burn through any material. And I can talk more about that stuff too, and I can do a live demo if you guys are interested. So here I'm just cutting out all the different shapes, which was super exciting because this was all made with just a few lines of code. I run a makerspace at TCNJ with my friend Brett, and we have like much bigger laser cutters there. So then it's just gonna glue them all together, and eventually you're gonna see what the thing actually looks like. Because it's burned, or to my laser cutter, it smells like a campfire in here, which gets old, like fun for the first couple cuts. And then all of a sudden, I got something that's kind of cool. Yeah, to line up all the dates, otherwise it's not right. Now, the first time I did it, actually didn't look like that. That was fake. That was not the first test. The first test I made looked a little bit more like something like this, right? And I thought it was so cool until I realized there was a major flaw in this. Mathematically, this was right. And this is actually a different country. It's not the original model. And usually if I show somebody this, they're going to ask like, why does the shape look weird like that? How come it's not smooth? What is that? So for the first time, I forgot to actually incorporate daylight saving time. Whoops. So like it didn't work as a clock, and I'll show you in a second how it's supposed to work. So like this is like the Monday we don't want to get up, like when we change the clocks back, like that part right there. So once I put all that together, let me show you actually what the model looked like and actually how it works. I didn't glue the base on because I was lazy. I should have glued it on. But here's the one you just saw. And the way this actually works, and let me line this up because I didn't glue it, is if it is just about the beginning of November, so we're here. So there's all the months right there. So if this is November and each of these is an hour, so that's midnight, 1 o'clock in the morning, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4. So right now the sun, according to this, the sun radiation is right there at this time of the year. And that was the big breakthrough right there. So based on the hour and where we are on the dial, like that's where the sun radiation. So I can very quickly tell like that half is winter, this is summer, and you can really actually when you hold it, you can actually see the shapes of how all this works. The guy who made the library, I emailed him because I had a question about something, and I showed him the stuff, and he's like, I can't believe the shapes look like that. I thought they would look like totally different. And he was like amazed. So I got to send him one. He's like, I can't believe I've been working on this library for like 10 years or something. And since 2007, which is more than 10 years, closer to 15. And he goes, I can't believe that's what the shapes look like. So he was super excited. So that was my first model, right? But then, of course, like you're going to want to test other ones. So the next model, obviously, New York City. New York City and New Jersey, almost identical. Like it's almost the same model, but if you look closely, there's actually some minor differences. So that was kind of boring. It's almost like a waste of glue and wood because it's basically the same model. There's some minor differences when you put them side by side. So then, like of course, as humans, we're going to want to know, well, what are all the extremes? So then I decided, let me try Australia. And so Australia looks a little bit like New York, not as like slightly different shapes, but it's backwards because it's in the southern hemisphere. And like I always heard about that, but now I know it's true because I put it on the laser cutter. I didn't know if it was actually true. Then I tried a really cold place. So this is Siberia, Russia. So in the winter time, it's like almost completely dark. In fact, I have another model with somewhere around here that's even more extreme. And overall the shape's smaller because it's got less solar radiation because it's so high up but near the northern hemisphere, way up high. Then I tried Cairo, Egypt, because I just wanted to see, because the pyramids, right? I figured it was like it's huge. Like this is such a bigger model than like the Russian one because obviously it's like closer to the equator. But I had to compare that against the brightest place on the planet, which is this place in Ecuador, and this is the largest model. Like it's basically like it's dark out, it gets crazy bright, and then it gets dark out again. There's not much like gradation. I tried a couple of others. I've got Beijing, China, and they don't have daylight saving time, so it's like it looks like a nicer model. Rome, Italy, which looks kind of like New York. And then I tried one more place, and you probably can guess where I tried, right? The most extreme places on the planet. Everybody want to give it a guess?
Hawaii?
Oh no! I should have tried Hawaii. That would have been a good place. No. Oh no! It almost broke. This is the station in Antarctica. So this is like right on the pole, essentially. So it's not directly on the pole, so you'll see like a slight curve. I did one that was exactly on the pole, and mathematically it's exactly the same shape. So in I guess it's the summertime, it's completely dark, and so like right now it's like November, like it's a tiny bit light out right now. And if we go to a webcam, I bet you we could actually see they have like a live cam of where the station is. You could probably see just a little bit of light. And I had to do it to make sure that was right. But then, like, around December, it's like bright 24 hours a day. So these are things we always kind of knew. But to build them just through like some code was pretty amazing. And they use this kind of code for like determine whether or not it's a good idea for you to install like a solar panel at your place. But we can make sculptures with it. So anyhow, I got these shapes, but that wasn't. I wanted to make the original model. So let me show you how I made the other one. How I started making these discs, because this required like a whole lot of research actually, like making these acrylic discs, and I'll show you why I made them. But here's a short clip. Is that Willard Brothers? They do woodworking. everything on the CNC machine, which is kind of like, again, like a Cricut, but instead of like a cutter, instead of like the cutter just happens to spin. And then I want to put them all together. Looks like the website. And then basically I just had to lay them all out. And then what I actually had to do, my plan is I 3D printed this little jig so that I could slide in the sliders, put some glue on there, put in one of the discs, put in another, and then glue that, then put the slider in. And I did a test to make sure the wood glue didn't stick to the PLA. And the test was great, but like literally when I glued it all up to try to line everything up, it like totally stuck. So I had to use a hammer and just like obliterate the model into a million pieces. And I was so mad. Like I couldn't believe it didn't work. I tested it. So I should have had footage of that because you would have seen me really upset because there was just pieces flying everywhere, just like hammers and things flying everywhere. But eventually got everything apart. I had to like resand everything and glued it back together just by eye. So it's not perfect now, but it's close enough. So now that was done, the whole point of this was to make it a lamp. That's why we made the acrylic sandwich. So let me show you this real quick. So I had these LED strips. I had a couple of these I glued together. These are slightly different ones. And if I thread them through this hole, when they're light, you'll see the ring of light. So you can always know exactly what time it is. So you don't have to count. So that my real lamp actually has like a ring of light depending on what hour it is. And for that, like since you guys just saw the Arduino thing, I basically just used this little timing circuit. There's a battery in the back, and then plugged into the Arduino. Wrote just a tiny bit of code. Like that's basically it. That basically just says every time we change the hour, make sure you change a different light. And that's all the code does. And so you're going to see that ring. And that was like the coolest thing. I wish it was a little bit brighter. If I had to do it again, I probably would have made overall the model bigger so I could put more than 2 strips in there. 4 would have made it a lot brighter, but no one's ever going to see this except for me. So that was pretty exciting. And yeah, so now what we're left with essentially, I'll go back to my shop cam. You're not going to be able to hear me for a second. So I don't know if you can see that ring of light. And so the sun's like shining on it. But it's just a little bit of Arduino code. Oh, and then there's this bottom piece. Let me see if I can rest it on there. Yes. So you're like, what is that? So for that, I'm not sure if I even like it. I wanted the base, because it's a solar lamp, I wanted the base to look like a sun. So this was a piece of redwood burl that came from a forest fire. And so like with the sun, like, fire and all that kind of stuff, and it looks like the sun. So that's what it was made out of. And then I went to Cut Sen, and I got some stainless steel and some brass cut out for the base. And I used a brass one, although I might switch it up, and I was able to laser engrave that. But the last thing that I need to do just to complete the whole metaphor is I need to make it solar paneled, right? Because it's a solar. It should be plugged into the wall. Like it shouldn't be powered by coal. It should be powered by solar radiation, by the sun. So that's like once I get this working, and it's almost done. I have to just like test it now. Then make the box and stuff like that. Then I'm able to, then it's like the project's done. They'll sit in the corner, and I'll always know how much solar radiation is over my shop. So for me, so like, why did you even create that? Like if I, and I think it's important that you're doing this because when you think about like the reason you're doing a hackathon, and I think a lot of you are students now, I think if you just work all the time, and I do, like for instance, Right now I'm making stuff for SJC drums. I don't know if anybody's a drummer. So like that's my big client at the moment. I've like 3 big clients. So I do a lot of work for other people, and I also teach. When you're just working all the time, like it starts to feel like work. You start to get burnt out, and it stops being fun. You're not motivated. So a project like this, for me, it enables me to follow my curiosity and to figure things out. So it's a completely useless project. Nobody cares about it. I probably couldn't even sell it for like $100, but it's mine. Like it's all mine. And so like now after this project, I'm so tired of it. I'm actually happy to go back to like regular work. So when I was a web developer for 12 years, we were doing big clients like Best Buy, and we were doing things like for these big hospitals, and we're doing stuff with the Connect and all these kiosks and for museums and stuff like that. And I was working and working and working, and I mentioned earlier I got burnt out. So having like a side project that you can work on the side goes a long way, just to like keep you motivated. It allows me to try some new techniques and things that I can't always try like on a job. So I always have like a side project going. Like my next one that I'm going to start on the side, that's not like work related, is this desk. I'm at like $1,000 in materials now, but it's going to be the craziest desk. It's all mechanical. It's hand cranked. It's going to have all these different kinds of tops, and it's going to, it's going to be amazing. Yeah. But no one's going to want this desk except for me. Like it's made for me. And that's what I love about digital fabrication. And you can make things that are just for you. No one else has to like it.